All right, here we are again. So let me just get everything open and we'll start. All right, let's see. So I believe we left off with, we have the problem sets. Oh boy. Okay, let's start with that. Very good. Hold on one second. Let me get them open. Okay, hold on one second. What's today, the 18th? Yeah. All right, so this is what we have. So there's actually only 7 problems here, but they're kind of time consuming. So we'll look at those. And then we've also got chapter 15. So we'll begin at the beginning. Now here we have a case where we've got 3 exchange rates. And we have, and if you notice very carefully right here, we have a cross exchange rate. And so we want to know, if we have a trader who starts in Europe with 10 million euros, how can triangular arbitrage profits be earned? All right. So the first thing we need to do is first confirm that they're available in the first place. And that just means that the exchange rates are inconsistent with each other. So how can you tell if that's true or not? Well, let's see. Let's take a look at them all side by side. So the cross exchange rate is between the euro and the pound. All right. So why don't we do this? Let me do this in the equation editor. It might be easier to read it. Okay, so if we started out, for example, with the ratio of US dollars, I don't think I have any symbols in here for the currency, so I'll just write out the letters. We have USD 173.95. There we go. USD for dollars, of course. Hold on a second. USD. Man, this thing doesn't want to work, does it? Unbelievable. Hold on, let's try. I don't know why it keeps doing italics. I mean, I'm not asking it for that, but all right, 1.7395 divided by Great British Pound. If we were to, here we go. We should divide that. So let me put this in the numerator. Or you know what, actually, it might even be easier if I do it this way. I'll put the ratio of 1.7395 per pound in the numerator, and in the denominator, I'll have 1.1893 per euro. So what this means then is that you've actually got, let's start with this. All right. Either that, or you know what, I'll tell you what, let me just do it by hand. It's so much easier. Let's get this going here. Let's try it this way. we start out with 1.7395 per pound. And then what we can do is divide by 1.1893 per euro. Now, this is algebraically equivalent to 1.7395 per pound, and then we're going to multiply that by the inverse of this denominator. So now what this actually means then is that the dollars cancel each other out. And now you've got so many euros per pound, which is what we're aiming for. So we'll figure that out in a second. 1.7395 euros is required to buy 1.1893 pounds. And so that reduces to 1.18, hold on. 1.7395 divided by 1.1893 equals approximately 1.4626 per pound. This is the cross exchange rate that's implied by these two exchange rates that involve the dollar. Now, as you can see, the quote that you were given is not equal to 1.4626. So that means that we have to figure out how to take advantage of this and earn some triangular arbitrage profits. Now, what we can do here, now, unfortunately, there's different ways that we can arrange the circles. And the way you approach this will depend on how you've chosen to do that. But ultimately, the logic is exactly the same. So, for example, in my case, when I drew up these answers, what I did was I put dollars in the bottom left-hand corner. And then I put euros in the center. And then I put pounds down here. Now, if you didn't do it this way, the direction in which you go might be different. But the actual transactions will be exactly the same. Now, we know, or we're assuming, that this particular trader, let's see, there it is, starts out with 10 million euros. Okay, so what we can do is start up here and make it clear that we're starting with 10 million euros. And now the question is, which direction should we go? Well, let's look at the actual or the implied. We can think of this, by the way, as the implied cross exchange rate. The actual quote we were given shows that it takes too few euros to buy a British pound. So you can think of it as being the ability to buy pounds is too cheap with this quote. So what we're going to end up doing when we go around the circle is make sure that at some point we buy pounds and sell euros. Okay, sell euros to buy pounds. All right, and again, the logic is, according to this implied cross exchange rate, each pound should cost 1.4626 euros, but here it's actually only 143.81. It's almost like the pound went on sale at this dealer. Okay, it's too cheap. So you can think of this: the pound is too cheap. And of course, that implies that the euro is too expensive. And that means, as you know from arbitrage, you buy whatever's too cheap and you sell whatever's too expensive. So somewhere along the way, you must buy pounds and sell euros. So since we're starting with pounds rather, or no, sorry, we're starting with euros. That makes it very simple because what we want to do now is sell the euros that we started out with in exchange for pounds. So that means we're going this direction. Okay, so when we go down in this direction, we're selling euros and we're buying pounds. And that's exactly what we were aiming for. So remember, this was given to us, this quote is not the implied quote, but the actual quote, 143.81. Per pound. And so what we need to know now is how many pounds were we able to buy with our 10 million euros. So we're going to actually divide here. Okay, so in other words, 10 million euros divided by this number, 1.4381 per pound, means that we end up with, and so we do the division, and we should get 6 million. Okay, this is how many pounds we're going to get. I'll put it up here, by the way. 6,953,619. And we can just leave it at that. You can round it to the closest pound or the closest dollar or the closest euro. Okay, now we have pounds. And so what we're going to do next is sell those for dollars. Okay, so how does that work? Remember, the exchange rate here that we were given is $173.95 per pound. And so when we have the number of pounds and the dollar pound exchange rate, we're going to multiply them. All right, so let's do that and see how many dollars we get. All right, 1.7395. Okay, we multiply that by 6,953,619 pounds. And so if we multiply those out, that'll give you 12 million. Actually, let me write it up here. $12,095,820. Okay, and then finally, we need, because this is a European trader, we need to at some point convert all these funds back into euros. So the spot exchange rate between the dollar and the euro is 1.1893. And so this time I'm going to divide. Okay, so if I take 12,095,820 and divide by 1.1893, you'll see that we have the final result, which is 10,170,538 pounds, euro rather. So of course our profit is the difference, 170,538. And so all of this came about because this exchange rate is inconsistent with these other two. It's too low, all right? The price being asked for the pounds is too low, so this is how we take advantage of it. All right. So now, again, like I said, if you put the circles in a different order, it's possible that you would have needed to go counterclockwise to make money. But the bottom line is, once you go around the triangle, if you've made money, you must have done this correctly. If you lose money, you obviously got it backwards. You just have to go the opposite direction. The only tricky part is, sometimes you have to realize, sometimes it can be a tricky decision whether to multiply or divide to get from one currency to the next. But the bottom line is, if you perform an operation in which the currency you do not need cancels out, that means you've done it correctly. All right. So that's our result, and that's our final profit. All right. Now we've got a similar one here, except that now involves the NAFTA countries. We have Canada, Mexico, and the US. And so in this particular case, what we want to do is, once again, see if this cross exchange rate is consistent with the other two exchange rates. If not, then we can earn some profits. But if it is, then there's no profits to be had, and we would be done. That would be the end of the problem. All right, so let's see. So in this case, let's figure out whether or not the cross exchange rate is consistent with the other two. Now, how do we do that? Well, let's see. If we had Mexican pesos, 8 point, let's see, how would this work out the best? Let's try this. Yeah, this is not what we want. Okay, no, I think it's fine the way it is. All right, I'll show you why. If we have Mexican peso, 8.7535 per dollar, and we divide that by Mexican peso. No, that's not what I want. I want the Canadian to US dollar. So we'll call it CAD for Canadian dollar, 1.419. So in this case, these just drop out. So whatever I end up with is Mexican pesos per Canadian dollar, which is what I want, 8.7535 over 1.419. So when we're done, we end up with that ratio, which is 8.7535 divided by 1.419, which is 6.18. 6.1688. And per Canadian dollar. Now, is that what we were given? No. Okay, you can see it takes too many pesos to buy 1 Canadian dollar. So we can think of this as the Canadian dollar, CAD, is overpriced, and the Mexican peso is therefore underpriced. Okay. So that means that somewhere along the way in this circle, we have to make sure that two things happen. We must sell Canadian dollars and buy Mexican pesos. okay? It doesn't matter when, but before we get to the end, we have to have bought pesos and we must have sold Canadian dollars. And in fact, we can set it up so this takes place in one transaction. So why don't we do this? Let's put Canadian dollars on top. All right. And then let's say US dollars could be here. Mexican pesos can be here. And then we're assuming that this is an American trader who starts with $1 million, and we're going to find out how to make profits. So we start with $1 million. Now, if during our travels, we're going to want to make sure that we sell Canadian dollars and buy pesos, that means somewhere along the way, we have to move down this branch. Okay, sell Canadian, buy Mexican pesos, which means that we must go up in this direction. So the quote that we were given for Canadian to US is C, 1.419 per US dollar. So this means that we actually have more Canadian dollars than US dollars. So we're going to multiply. So the US dollars drop out, and we end up with 1,419,000 Canadian dollars. Now, we can come down here. This is where the incorrect cross exchange rate is. We've got pesos, 6.439 per Canadian dollar. And so what we have to do is take this number and divide by the number of pesos, or actually multiply, sorry, we're going to multiply, and we end up with 136,000. Sorry, 136,000. Sorry, let's try that again. 136,000. 941. There we go. Oh. All right, let's try that again. 136,941. Now, finally, we need to bring these pesos back to the US. They have to be converted into dollars at the exchange rate of 8.7535 per dollar. All right, so this time we're going to divide. All right, so if you look at this, 9 million plus pesos over 8.75 pesos per dollar, clearly that's going to leave us with more than $1 million. Okay, and so that ratio ends up being 1,043,804. So the profit is obviously the difference between those two, $43,804. Okay, so now it's all said. So the key to the whole thing is to decide which direction to go. They're telling us which country or which currency we're starting with and how much. So after we organize the circles, we just have to decide which direction to go in order to make money. Depending on which way, the cross exchange rate is inconsistent with the two spot rates. And so in this case, you can see we clearly did it correctly because we ended up with a profit. All right, so these are all they're very similar to each other. The bottom line is that if the this cross exchange rate is inconsistent with the other two, that means one currency is artificially overpriced and the other is artificially underpriced. And the logic is always buy what's cheap sell what's expensive. That's always the bottom line. All arbitrages work that way. Now, how about these? Well, let's see. We've got the 6-month spot exchange rate between the dollar and the pound is 1.75, $1.75 per pound. The US 6-month rate is 3%. For the UK, it is 6%, or 5%. And we're looking at 6 months or 180 days as the time until the forward contract that we're entering into will mature. So they want to know, what is the 6-month forward exchange rate that prevents arbitrage profits? Or that's just another way of saying calculate F from the interest rate parity condition. And that's all you have to do. Okay, so if you plug in those numbers, let's see what happens. 1.75. Now here we have 1 plus, the US rate is 3%. And here we have 180 over 360. Down here, we have 1 plus 0.05 times 180 over 360. So basically, you're cutting the rates in half. This is the equivalent to 1.015 over 1.025. And the final result here is $1.6916 per pound. This is where it should be. But we're going to soon, oh, actually, no, in this problem, that's what we have to do. Oh, wait, I'm sorry, I copied the wrong one. Just hold on 1 second. This is not right. This is the answer to the next problem. It's actually 1.7329. That's better. Yeah, there's no way it could have been that far off. Okay. Yeah, I just copied the wrong thing. So that ratio times 1.75, you can see it has to be less than 1.75. Okay. Yes, 1.7329. That's fine. And that's it, because all they wanted to know is what is the 6-month forward exchange rate that prevents arbitrage profits. In other words, what is the 6-month forward exchange rate at which this condition holds? Excellent. Now here, they will ask us to actually show how arbitrage profits could be earned if the forward exchange rate is different from that implied by interest rate parity. Okay, so remember that, yeah, this is the interest rate parity condition. So we're going to apply the same one down here to these numbers. So we have $1.70 per pound. And then 90 days for N. Euro dollar rate is 2%. And the euro sterling is 4. All right, well, we're going to plug in all the numbers and see what it should be before we decide what to do in each of these two scenarios. Okay, so we'll have 1.70 times 1 plus 0.02 times 90 over 360. And here we have 1 plus 0.04 And this one is not, again, 90 over 360. All right, so basically we're dividing both of those interest rates by 4. And so what you've actually got here is the ratio of 1.005 divided by 1.01. And when you multiply this out, you should get approximately 1.6916. So here, the reason why we need this is because you can see that they're asking us to figure out what to do under these two scenarios. And it's been set up on purpose so that in one case, the forward exchange rate that's being quoted is too high. And in the second case, it's too low. So we get to see each one separately. Okay, so now here's what we have to think about. In the first case, F is too high, in the sense that each forward pound costs too many dollars. Okay, now what does that mean? It means that the forward pound is overpriced. Which means that the spot dollar must be underpriced. Actually, I'm sorry, it's not. What am I saying? It's not spot. It's forward as well. The forward dollar. Which means that sometime during our procedure here, we must buy, or actually we should sell pounds forward. Sell forward pounds in exchange for forward dollars. That's our strategy. The rest of it falls into place once we know how to do that. So remember, we have this diagram that we can use. If we assume that we start with $1 million in the US, the diagram actually has 4 corners to it. And so what we're going to do is the following. We start with our $1 million in the United States. We convert them into pounds at the currently observed spot rate of $1.70 per pound. And that will bring us, and by the way, here we're dividing $1 million divided by $1.7 per pound is 588,000. $235. Let's, yeah, we can just leave. No, all right. I guess we can round it to pounds and pence. Okay, now once we have those pounds in our possession, we don't actually, we want to earn interest on them. So we're going to put these in the euro sterling market rather. Okay, this is the euro sterling market. And you can see that the spot, the interest rate in the euro sterling market is 4% right here. Okay, but this is only a 90-day investment. because this is a 90-day forward exchange rate. This is a 90-day investment. So we can put that here in the middle to remind ourselves. And so when you multiply to see how much money you'll have in 90 days, what you're actually doing here is taking this amount and multiplying it by 1 plus 0.04 times 90 over 360. So in effect, you're multiplying it by 1.01, or in other words, you're earning 1% over those 90 days. And that brings our balance to 594,117.65. Now, here's the interesting part. That's not going to do us any good because there's going to be foreign exchange risk. So what we will do is when we enter into this, our pounds into this bank account, we'll simultaneously sell this many pounds, 594,117.65, through a forward contract. And now the forward price or exchange rate is this $1.71, which we know is too high. We're going to get too many dollars back for each pound that we sell through this contract. So we're going to end up collecting, when you multiply these two together, you'll get 1,015,941.18, and that's what we collect. But here, when we pay back the loan that we presumably took to get this money, where we paid 2% in the euro dollar market, because this is only 90 days, we're basically paying 0.5% worth of interest, which means we're repaying $1,005,000. Okay. And obviously we made money. In fact, we made more than $10,000. The difference, oh, I just realized I wrote the wrong thing here. The one on the top is the repayment of a loan. So let me change that to repay. And so now it should be clear that we're collecting more than we're repaying by about, it's actually $10,941.18. And that's how we made our money. So the key to the whole thing is right here. We were able to sell these pounds for too many dollars because the forward exchange rate is simply too high to be consistent with these other variables. Nice. All right. Now what we have to do is work this backwards based on the assumption that F is actually 168. It's too low. Okay, the forward pound is underpriced. The forward dollar is overpriced. So we want to work everything backwards. But that requires us to start with pounds rather than dollars. So that's what makes it a little tricky. Okay, so in other words, we want to basically reverse what we did up here. The forward pound is underpriced. So in the second case, when this is $1.68 per pound, this tells me that the forward pound is underpriced, the opposite of what we had here, which means that the forward dollar is overpriced. And somewhere along the way, we must buy forward pounds, sell forward dollars to take advantage of this. So how do we do that, though, with this diagram? Well, in a lot of ways, it'll be very similar. So just to keep it consistent, why don't we assume that we'll have $1 million in the US, but keep in mind that this time around, we're starting with pounds. We have to start with pounds because at some point we need to sell our pounds forward and, sell our dollars forward and buy pounds. So how would that look? Well, we're going to start in the bottom left-hand corner. We're going to acquire or borrow $1 million worth of pounds. So you notice this amount right here is the same as it was in the previous example. Because if I multiply that now by the spot exchange rate of $1.70, I'll end up with exactly 1 million pounds. So I borrowed, in this case, pounds. So we start by borrowing pounds, convert to dollars, deposit in a euro-dollar account, enter into a forward contract to sell dollars for pounds, and then repay the pound loan. That's your basic strategy. And if we've done this correctly, we should end up making money. So now here we're going through the euro-dollar market for 90 days. So we end up, in this case, our investment ends up being worth $1,005,000 at the end of 90 days. Now, because we know that we'll have this in 90 days, we also simultaneously enter into a forward contract in which we agreed to trade those dollars for pounds at a forward exchange rate of 168 per pound. Okay. So when we do that, if you multiply these together, actually you're dividing. If you divide $1,005,000 by $1.68 per pound, you'll end up collecting in 90 days $598,214.29. And your loan, remember we borrowed the pounds this time, for 90 days, that means you're basically paying back 1%. So that's going to cost us $594,117.65 that we repay on our loan. And so the difference between the two is our profit. All right, so if you subtract one from the other, you'll get, what is that, 4,000, let me use the calculator. It's getting late at night here. 598 million, or 214.29 minus 594,117.65. So that's a tidy little profit of 4,096 pounds and 64 pence just for a few minutes work. Okay, so this is our profit. But you notice everything works in reverse. Also, it's denominated in pounds, but that doesn't really matter because it's still a profit. Okay, if we want dollars, we can trade them for dollars. Okay, well, the hard part is over, I think, because now we can do some graphs. These two are really, to me, are the most challenging, but, I mean, you might disagree and think that the triangular arbitrage is harder. They're both hard. Let's put it that way. Okay, so anyway, the only good thing about this is that there's only two different ways you could go. You could start with dollars like we did before and end up with dollar profits, or you could start with pounds and end up with pound profits. Okay, so, and if you go the wrong direction and you end up with losses, it just means go the other way. So it's easy to stop yourself from making a mistake. All right, now here we get to show off our graphic skills. This is our asset market approach that we've seen, we've been looking at. And so what do we do here? Well, first of all, what we know is that the euro dollar rate is 3%. Euro sterling is 4, and the expectation is of $1.50 per pound in the future, 1 year. So you might recall that this basic model that we're starting out with is this one. All right, that's the basic asset market approach. What we needed to do to solve for the equilibrium rate of exchange rate, rather, is to simply rearrange this algebraically and solve for E. And when we do that, I'll save you the steps. This equals the following. Okay, so what we can do, and right here, according to this in part A, we're being asked to calculate the equilibrium exchange rate according to the asset approach to exchange rate determination. So here, all we have to do is plug in some numbers. The expected exchange rate is $1.50. Here we have 1 plus the US rate of 3% minus the UK rate of 4%. So it's 150 over 0.99, and that works out to $1.51.52 per pound. Okay, now in part B, we're supposed to show this graphically. All right, so here we have the exchange rate dollars per pound. Here we have the rate of return. The US rate right here is 3%. This is where they cross. And we've just seen that that is the equilibrium exchange rate, which is 1.5152 per pound. And that's all they needed us to do. Now, part C, we're going to be asked to recalculate this based on the assumption that the euro sterling rate rises to 5%. Okay, so this is part B. Part C asks us to think about what happens if the euro sterling rate of interest goes up to 5%. All right, so we're changing a couple of things. We still got the US rate is 3 and the UK rate. And the expected exchange rate is $1.50. All right. All right, those haven't changed, only the UK rate. So what happens? We have 1 plus the US rate minus the UK rate. 1.50 for 1 plus 3% minus 5%. And that works out to $1.5306. Now, how would you show that on this curve? Now, here's what I'm going to do. I'm going to cheat a little and copy this down below. You don't have to do this. You can draw everything on the same curve. And what I'd like everyone to see is what reaction we have. So remember, it's the UK rate that changed. All right, actually, you know what we have to do. I can tell, you know what, I've been having trouble with this whole week. The thing about Word is that it can only store so much at a time. So I'm going to move this onto a new document just to be on the safe side. And I'll fix this later before I send it to you. But I think it has run out of memory and it's not happy. So let me just quickly see what I can do with it. We certainly don't want to lose anything. Okay, we're good. All right. Carry on. Yeah, I've been running into this all week. The only bad thing about all this handwriting, although as wonderful as it is, it apparently sucks up a lot of memory, and Word can only handle so much. So the strategy that I use is to copy it or take it off the flash drive and onto the desktop, which has more memory. And that apparently helps. All right, so let's see what we can do here. All right, so let's see if I copy this, and I'll know right away how it reacts. No, that's good. Okay, it's perfect. So what I would like to be able to do is keep this all in the same axes. This is now D, where we're going to show graphically what just happened. So we already know that the British rate went up. And so right here, let's say this is equilibrium point 1, this is 2. Let me try that again. All right. All right, this is better. So this, we'll call this R1 because that's the original British rate of interest. And so finally, at our new equilibrium point, we have a higher exchange rate. The US dollar has weakened. It has depreciated up to 1.5306 per pound. Okay, and that's because of this change in the UK rate of interest. Okay, now in the next question, okay, yeah, we're good. In the next question, what's happening? Oops. Here we go. I almost lost something. Assume that the euro-dollar rate of interest is 3%. The euro Swiss franc rate, I'll just write that as RSF, is 2%. And the expected exchange rate between the two currencies is 95 cents per Swiss franc. Okay, so what is the equilibrium exchange rate? Well, once again, we have the formula. E equals EE. And in the denominator, we always have 1 plus the US rate. And we always subtract the foreign rate. So here we'll have 0.95 over 1 plus 0.03 minus 0.02. And that's going to leave us with 0.94, let's say, 0.59 dollars per Swiss franc. Now, let's say graphically, what does this look like? So here the spot exchange rate is dollars per Swiss franc. The US rate is 3%. Now here we have the Swiss franc rate plus the expected appreciation or depreciation. And where they cross, we have 0.94059 per Swiss franc. Now in part C, they're telling us that the euro dollar rate falls to 2%. All right, so the previous time it was the euro sterling rate. Now it's euro dollars. US rate dropped. All right, so the new euro dollar rate is 2%, but the rest haven't changed. All right, the Swiss franc is still 2. And the expected exchange rate is still 95 cents per Swiss franc. All right, so what happens now? So we plug these into our formula, which once again is here. So we start with 0.95 in the numerator. So we end up with 0.95 over 1, which is easy. It's just 0.95 cents per Swiss franc. And so in part D, we'd like to show that graphically. Yes, we'll copy this. That should be okay. And then we'll see what happens when the US rate drops. Okay, so we know that the US rate dropped from 3 to 2%, which means we move it over here. And as a result, the exchange rate went up to 95 cents per Swiss franc, which means, of course, that the dollar depreciated as a result. And that's what you'd expect. When the US rate drops, the dollar depreciates. Up here, when the euro sterling went up, the dollar depreciated, again, because the interest rates are relatively now lower in the US. All right, there's one more here, which involves euro dollar rate Euro dollar rate is 3%. The Euro krona rate, now that's the Swedish currency, by the way. I'll write RSEK for Swedish krona, 0.01, and the expected exchange rate is 15 cents US, that is, per Swedish krona. All right, so what is our exchange rate in equilibrium? E equals EE over 1 plus the US rate minus the, in this case, Swedish rate, 0.15 over 1 plus 0.03 minus 0.01. And so where do we end up with? This is 0.15 over 1.02 means that it takes 14.706 US cents to buy 1 Swedish krona. And so graphically, how can we show this? All right, the US rate, once again, was 3%. And here we have at where they cross, we have the equilibrium exchange rate of 0.14706 per krona. All right, so now in part C, what changes? Oops, I have to fix something. I have to move this one more time. All right, so we have in part C, they tell us that the expected exchange rate rises to 0.18. Okay, and so the question is, what does that do to the exchange rate? So the US rate still stays at 3. The Swedish rate is still 1. And so remember this formula. We'll give it a minute to save it again. So the formula that we need is this. We have E equals E over 1 plus the US dollar rate minus the Swedish krona rate, 18 over 1 plus 0.03 minus 0.01. All right, so the ratio is, let's see. Oh, it's now 0.1717 647 dollars per kroner. And now we have to figure out how to graph that. All right, that change, I mean. Wait a minute. Okay, so we'll just grab this graph and see how that change happens. All right, beautiful. Okay, so this is part D. And so what's happening here is that it's the expectation that's changing. It's going up. So this curve shifts to the right. And so at our new equilibrium, we have a higher exchange rate, meaning a weaker dollar, which is 0.17647 per kroner. And that's all we needed for that one. All right, well, guess what? That one's done. Wow, that was tough. It's done. But now we're ready for 15. All right, let me just save this one. Make sure that it's working. Okay, that looks good. Now we can get rid of this one. All right, we can get rid of the weather, which forced itself on us. And now we can go back and get chapter 15. Okay, so that one is a lot less theoretical. So let's take a look at it. First, let me print this out. And we can open up the actual questions. Oh, well, this one's quite short by comparison. And while we're at it, this is fine. I'll save it here. Okay, so what's going on here? Now, some of these are just short answer, but we do have several graphs that we have to do as well. All right, for example, what are the components of the monetary base? So we can define it in two different ways. We can either define it as the reserves plus currency in circulation, or domestic assets plus foreign assets. And that means of the Fed, that is. Okay, so those are the two possibilities. It's usually the first one that we use in practice. Okay, and of course, the common thread they have here is that the Fed is completely in control of both of them. Now, what are the primary determinants of the demand for money, the real demand for money? All right, well, that's mainly three things: short-term rate of interest, the price level, and real GDP, a GNP. This book likes GNP. Okay, so either one is fine, though. Now, C, if the short-term rate of interest is above its equilibrium level, how do investors react? Okay, so this means that investors hold more money than they wish to because the opportunity cost of holding money is relatively high. They use some of their money holdings to buy interest-bearing securities or assets such as bonds. Now, in the process, this increases the prices of bonds, reduces their yields, and reduces overall interest rates in the economy. In other words, if it's too high, it will take care of itself. And this is why, because investors will not sit there and say, well, we've got more money than we want. We'd like to earn, in other words, what this means is that you've got way more money in your checking account than you really need. So what do you do with it? You may decide to buy bonds with it or other types of securities. And in the process, interest rates start to drop and we'll end up back in equilibrium. All right, now what assets does the Fed hold on its balance sheet? Well, there's a few. We could actually expand on this, but this is really what most of them consist of. We have bank loans. We have treasury securities. And we have foreign government securities. Okay. The Fed holds all of these at any given time, and those are all considered to be assets. Now, M1 primarily, although there's a few other small items in there, primarily consists of currency in circulation plus checking deposits. That's where most of it comes from. All right, now we get to do some graphs. All right, so this is where it gets interesting. All right, how does expansionary monetary policy affect the short-term rate of interest? All right, so the framework that we're using here is the one where we bring together the supply of money with the demand for money. Okay, so how does that look? So on the vertical axis, we have the US rate of interest. Over here, we have the quantity of money. And over here, the short-term rate of interest. So here we have US money supply. And remember, the money demand curve is downward sloping and it's designated LY, R. So we're assuming that we have expansionary monetary policy, which means that the nominal money supply goes up. Actually, let me fix this a little. So by the way, here's the equilibrium point. This is R1. And as a result of the expansionary monetary policy, the curve shifts to the right. And we end up with R2. You could call this Q1 and Q2 if you want to. The important detail here, though, is that the nominal money supply, the real money supply increased, and as a result, the nominal interest rate dropped. All right, so this is what the Fed is trying to do when they engage in expansionary monetary policy, their goal is to stimulate the economy with lower interest rates. They know that consumers will spend more, they know that businesses will invest more, and the size of the economy will expand. All right, so here though, our job was to show that graphically. All right, and that's how we do it. Now here, oh boy, look at this one. This is the one where we brought together the money market graph, which is this one sometimes, by the way, is known as the money market. This graph is meant to represent money market, which is where the supply and demand for short-term interest-bearing securities are interact with each other. Okay, but down here we're combining that with the foreign exchange market. And you might recall that this is done in a very oddball way. We actually, in order to bring them together, we actually have to turn the money market curve on its side. So this one is quite a challenge. It can be done, but it's tough. We just have to be a little careful with it. So we're assuming that it's the pound. And this is our equilibrium up here, which has to coincide with equilibrium down below. How do we ensure that that happens? All right, well, first of all, what's going on this vertical axis is this is the quantity of money down here. And here's the money, real money supply. The demand curve looks something like this. And this is where they cross. So in other words, the interaction between the real money supply and the real money demand gives us the domestic rate of interest. That, when combined with the expected return of the foreign currency, gives us our equilibrium exchange rate in the foreign exchange market. Okay, so that's why we can show them both together at the same time. The one axis they have in common is the rate of return or rate of interest, which is what we're looking at here. So that's kind of a pain. But, you know, I mean, it's bad enough. I mean, imagine when we start shifting curves around. Now, in part 4, then, we have to take the same setup and show what happens when there's expansionary monetary policy. Ooh. All right. So, well, all we can do is give it our best shot. All right. So we have to allow, or we have to show expansionary monetary policy and how it affects the dollar. All right. Well, let's do it. So we'll start by showing the equilibrium position. Whoops. We have the pound plus the expected appreciation or depreciation. Here's the equilibrium. And we come down here and we show equilibrium in the money market. Okay, so this is our equilibrium position. So what we have to do is change that by engaging in expansionary monetary policies. So, oh wait, I'm sorry, I got it backwards. It's contractionary. So, I almost blew it. So I don't want to go through this again, if I can help it. So contractionary means the money supply shrinks. And in this graph in the bottom, that means the money supply curve shifts up. Okay, I'll call it MS2 over P, where the intersect is 0.2, where we see a higher US rate of interest, which is what they're expecting. And so as a result, we have a stronger dollar. And that's exactly what we would have expected. Okay, so contractionary raises the US rate of interest, which makes the dollar stronger. And that's the whole thing. Okay. God, what a mess. But we did it. Now, the last one, luckily for us, it's a little simpler because it involves UK monetary policy. We do not have to worry about the US money market. So we can get away with our simple diagram, just the top part, just the foreign exchange market. Right? That's all we need to illustrate what happens with a change in UK monetary policy. All right, so let's try it. Now, of course, contractionary UK monetary policy will increase the UK rate of interest. All right, so we started here at 1, and the UK rate goes up. So this entire curve shifts up or to the right, depending on how you look at it. And so we move up to 0.2, where the dollar is weaker. And that's again what you would expect, given that the UK rate has gone up. Okay, so the dollar is relatively less attractive. Investors will shift their funds out of the US and into the UK. And in the process, the dollar gets weaker. All right, so that one's done. Wow, that's cool. That means we can go on to chapter 16, but not before we have, of course, our usual break. We have to have a break after all of this. Don't worry, we'll start up. 16 is a very interesting chapter. So we'll start that when we get back from the break. And so in the meantime, let's see. Yep, that's it. So when we're done with the break, we'll just come back and do as much of 16 as we can before the time runs out. All right. So I'll see you all in a little bit. Ah, all right. So we're ready for 16. I'll put these up, of course, on, I'll post these solutions on Blackboard later on, but right now, let's get to chapter 16 and let's see what that's all about. Now, at some point, of course, we do have to have an exam. Let's worry about that next week. But before we do that, we'll have a what we call a sample midterm, where you basically get to see more problems from the chapters that we'll be covering. And so I'll post that during the week. And then, in fact, why don't we look at this right now while I'm thinking about it? The sample midterm is right. Let's see, where did I keep it? This should be it. This is the sample midterm that I've given out in the past. You know what? That's pretty much what we've just been doing. All right, I'll tell you what, I'll post this on Blackboard, and why don't we agree that we'll work on this next week, and then I can give you the actual midterm, which of course you'll do at home. And, I can give you some time to get it done, at least a week, let's say. And I think you'll find that it's pretty straightforward. It's basically everything we've done up to, looks like up to 15. So that worked out perfectly, didn't it? Yes, exactly. Everything we just did tonight. The chapter 14 and 15 problem sets perfectly coincide with the sample midterm. So let's just do that. I'll post this on Blackboard, and then you can work on it for next week. And then I'll just post the actual midterm, and then you can have, let's say, a week to get it done. A week or so, let's put it that way. So, all right, that sounds good. In the meantime, then let's go visit chapter 16. And let's see what this is all about. Here we go. Now, okay, here's what's different all of a sudden. Up to this point, we've been looking at what we will call the short run. In economics, there's often a distinction made between the short run and the long run. And usually what separates the two is the time frame involved for an important variable to change. So here, that important variable is prices. So in other words, we're going to assume that in the short run, prices are fixed. All right, they don't have enough time to adjust to changes in the economic environment. In the long run, though, prices are flexible, which means they can change. And that means that inflation can change, and that can affect our results. So we're also going to, in this case, look at the idea that in the short run, foreign currencies are primarily held as investments. Okay, and so in other words, investors are simply trying to hold or earn the highest possible rate of return. But in the long run, foreign currencies can only be used for one thing, and that's to buy foreign goods and services. And so we're going to assume that while in the short run, investors are mainly trying to earn the highest rate of return, in the long run, investors are trying to acquire the best and the most goods and services. So therefore, in the short run, typically the countries with the highest interest rates will have the strongest currencies, but in the long run, the strongest currencies will be the ones where the country produces the best products. And so the focus is very different in the short run and the long run. All right. So with that being said, we're going to be looking at the so-called international parity conditions, which show the relationship between exchange rates, prices for the first time, inflation, which again, we haven't looked at before, and interest rates. Interest rates are always a major determinant of exchange rates, but in a different way in the long run than in the short run. We're also going to introduce a very interesting idea, and that is the so-called real exchange rate, which is sort of a variation of the nominal exchange rate that we see in everyday life, but it is adjusted to take into account the price levels of two different countries. All right, so why don't we start with the international parity conditions? Now, these conditions are not arbitrage conditions, okay? Now, remember, in chapters 14 and 15, or at least 14, we looked at least two parity conditions, arbitrage conditions. We had the triangular arbitrage and we had the interest rate parity, where if those relationships were violated, we saw that arbitrage opportunities can take place. We don't have that here. These are not arbitrage-free relationships, which means that they're violated, there's no opportunity to earn arbitrage. It's a very different situation here. We're just going to assume that these should hold in the long run, but there can be short periods of time in which they do not hold. And you can see there's 4 of them, and they're called purchasing power parity, relative purchasing power parity, the Fisher effect, and an extension of that to the international sector called the international Fisher effect. All right, so let's look at these one at a time. And it turns out that they're all actually closely related to each other. They just focus on different variables. Okay, so what about this purchasing power parity? What is that all about? So by the way, from now on, we're going to call it PPP to avoid having to say purchasing power parity all the time. And this version is actually referred to as absolute purchasing power parity. And according to this doctrine, exchange rates are ultimately determined by the price levels in 2 different countries. Before we go any further, though, I do want to take a step back and talk about price levels. So a price level or a price index is a number that reflects the cost of goods and services in a country. So one of the most famous price indices, or I shouldn't say famous, one of the most widely used price indices in the United States is called the Consumer Price Index, or CPI. All right, what exactly is this thing? Well, it's a number that's published by the Bureau of Labor Statistics every month, and it is an attempt to capture the cost of living. All right, let me sneak this in here. So the CPI is meant to reflect the cost of living. And now the index is specifically meant for what they call a typical urban family of 4. All right, that's how they define it. So the Bureau of Labor Statistics has created a basket of goods that it considers to be the typical goods bought by, again, the urban family of 4. And so what they have to do, the CPI comes about, is obtained by pricing these goods in the market. So they literally have to go out there and shop, and they find these goods, and they calculate what the new cost of living is based on this basket of goods. Now, if you want to see what the actual numbers look like, well, actually, in one of my other classes, I downloaded some information about these just the other day. So, in fact, why don't we go back here and see if I can find them? Maybe not. Let's see. No, it wasn't this class. It was macro class, where I looked up the current CPI for the US. Here we go. I'm going to copy these into our folder so that I can post them on Blackboard. All right, so let's take a look at these one at a time. Now, first of all, CPI. What I've got here for you is this is what the Bureau of Labor Statistics uses to calculate the CPI. Now, if you notice, it's broken down by categories. So they start with food, and this number on the right tells us that that is considered to represent about 14.119% of that typical urban family of four's yearly expenditures. And then they break it down a little further. For example, food at home is 7.772%. Food away from home, meaning, of course, restaurants and fast food places, is 6.347. Now, of course, you see they break it down even further. So, for example, fruits and vegetables end up accounting for roughly 1.341% of our typical budgets. We also have energy, which is broken down a little bit further. We have fuel oil, for example. We have motor fuel, energy services, electricity, et cetera, et cetera. And then we come down here and we have all the rest. So we have, for example, apparel. We have new vehicles, medical care, alcoholic beverages, tobacco, you name it, it's here somewhere. We have rent, owner's equivalent. This, by the way, is a number that they create. The idea here is that not everybody, of course, rents. A lot of people own their own homes. And so what the BLS tries to do is estimate what kind of rent they would have had to pay if they didn't actually own that property. So that's what that number is meant to represent. And then we have physician services and all the rest. So this is basically the breakdown of the goods that belong to the basket that they created to calculate the CPI. So this is what the basket consists of. And you notice it's up here, the Consumer Price Index for urban consumers. And these are the actual numbers. Now, these numbers tell us the following. If you go back into this other spreadsheet and look at the history of the CPI, let's take a look at that. What these numbers represent is the CPI going all the way back to 1982. And the reason why that's relevant is because what they've actually done here is they've picked this period in here as what they will refer to as the base year, a period during which the CPI would be set equal to 100, so that the number we have now, which is currently, as recently as January, 261.582. So what that means then is that the price, the cost of living is about 2.6 times what it was in the early 80s. So that's what that number actually means. It doesn't mean it costs this much to buy the basket. It means that the price of buying the basket, or the cost, is about 2.6 times what it was during the so-called base year. Now that sounds like a big increase, but in reality, that translates to an average price increase of about 2.5% per year. Now, the inflation rate that you hear discussed in the media or in the financial press is nothing but the percentage change in the CPI from one year to the next. So just as a quick example, if you look here in January 2021, our CPI was 261.582, and the year before it was 257.971. So the 2020 inflation rate could be considered to be the percentage difference between those two indexes, which means you're taking the current level minus the previous level, all divided by the previous level, and that works out to approximately 1.4%. So right now, US inflation is at a very low level, approximately 1.4%. In general, the Federal Reserve System tries to keep the inflation rate in the US from rising much above 2%. As far as they're concerned, that's acceptable, 2%. Less than that would lead to the risk of what we call deflation, And of course, deflation means falling prices. And while it sounds like a good thing, it's actually not, because it means that our debts become more expensive in real terms. And so this is why the Fed would like to avoid that. And in fact, the last time we had deflation, just to show you, was during the Great Depression. Anyway, so that's the CPI. And by the way, I also looked up this other interesting document, which shows where our inflation rate stands compared to the rest of the world. And you'll see that we compare very favorably. In fact, now they're listed alphabetically. So I'll tell you what, why don't I sort them? I'll just copy these two, and we'll go by last percentage just to see who's got the most inflation. Oh, sorry, wrong thing. Last percentage from high to low. Let's try that. All right, well, Venezuela and Zimbabwe, well, those are pretty high. But if we work our way down the list, let's look for the first Western countries that we can find. Wow, look at this. Some of these aren't that bad. But when we keep going down and down and down the list, and let's see. Mexico is only at 3.25%, which is not bad by their standards. New Zealand, 2.5%. God, even Russia is only at 2.5%. That's surprising. Wow. Iceland, 2.1%. United States, 1.5%. United Kingdom, 1.5%. Germany, 1.4%. So this is, one of those times, Netherlands, 1.4%, where most countries have relatively low inflation rates. Okay, Canada is only, 0.9%. Then Norway, 0.7%. Japan is probably way down here at the bottom. There it is, 0.4%. Italy, God, even Italy, for many years, they always had a problem with inflation. Greece is at 0, Israel is at 0, and then let's see, we've got some negative ones. Look at that, Switzerland has negative inflation. Interesting. Wow. Okay. Well, anyway, so enough of that. So let's go back here now. And so the idea here is that the CPI, whatever that number is, reflects the cost of living in the United States. And that's why it's called a price index. That's all it is. It's a reflection of the overall cost of living in the United States. Now, every country has an equivalent measure. Okay, so suppose we look at the UK, and because we're going to need that to compare them to each other to determine the strength of the pound and the dollar. So the equivalent version of the CPI in the UK is known as the retail price index, or RPI. Okay, it is also based on a basket of consumer goods, although it is certainly not identical to the US basket. All right, they have different goods and services in there, and the weights might also be very different. It's possible we could find this, by the way, if we go to the, let's see what we can do. Now, the British government has, I believe, a single statistical agency. Let's find it, see if we can quickly find out what's in there. There it is. The RPI for goods and services, and let's see. Well, that's what it looks like, but I wanted the actual contents. Oh, I guess we have to pay for it. Ooh, that's not good. Well, maybe not. All right, well, I thought I could look it up real quickly, but I just wanted to show you that it's not exactly the same thing, but it's a similar idea. It's simply a basket of goods that they believe that the typical consumers are buying during a given year, and they use that information based on whatever base year. Here, for example, it says January 87 to January 2021. I don't know what they consider to be their base year, but whatever year it is, oh, there it is. The base year for them is 1987. So that means 1987 would be set equal to 100. And so in January 2021, they were at 220.6 for goods, 404.3 for services. And so that's how we can tell how quickly they've risen, because 100 is not the year 1987. Okay. All right. Well, anyway, if you want more, it's here, although, some of it you have to pay for, I guess. Now, the first of our parity conditions tells us the following. Well, first, I shouldn't say that. The first one, purchasing power parity, is based on the premise that a good should sell for the same price in all markets, which is known in economics as the law of one price. Does that make sense? Well, it depends. You see, there's a lot of potential issues here. So just as a quick example of this, what if we discover, oh man, this is outdated. Gold is selling for $800 an ounce in the US. All right, let's just say that that's what's happening. And the exchange rate between the dollar and the pound is $2 per pound. That implies that the price of gold in the UK should be 400 pounds per ounce, because after taking into account the exchange rate, $800 in the US should be worth 400 pounds in the UK. So according to the law of one price, we'd expect to see gold prices in the UK at 400 pounds per ounce. Now, if not, at least in a case like this, we could earn what's called goods arbitrage profits by buying the gold in the country where the gold is cheaper and selling it in the country where it's more expensive. So if gold sells for less than 400 pounds per ounce in the UK, smart traders will buy gold in the UK and resell it in the United States. They'll earn arbitrage profits known as goods arbitrage. And then, of course, that will cause the prices to equalize again. Now, of course, the trading activity itself will push up the price in the UK and reduce the price in the US. And pretty quickly, the prices should be the same again. So even if the law of one price fails to hold, it should reestablish itself fairly quickly for goods where arbitrage is possible. But there's the rub, though. This doesn't work for all goods. All right, what do I mean by that? Yes, and I just want to mention, by buying and selling physical goods like this is known as goods arbitrage. All right, so I just want to mention here, though, that the law of one price, or there are several goods, many different types of goods, where the law of one price may not hold. For example, perishable goods. Suppose that a Big Mac costs $3 in the United States, and 2 pounds, oh, I forgot to, God, $3, and 2 pounds, all right, hold on, let me get that symbol. In the UK, and like before, the exchange rate is $2 per pound between the two countries. Okay, well, you know what this means then? It means that the law of one price does not hold. How do we know? Because if you adjust the British price for that exchange rate, The UK price in terms of dollars would be, and so we would go ahead and multiply the British price like we did with the gold by the exchange rate. And what would we get? That would be an implied price of $4 in the UK, compared with $3 in the United States. Okay, so like with the gold, there's a discrepancy in the prices between the two countries. This time, the Big Mac is cheaper in the United States. Than in the UK, after taking into account the exchange rate. The law of one price is violated. Now, here's the question. Can a trader engage in goods arbitrage in this case? No, because the Big Mac is perishable and would spoil if it was shipped between the two countries. Okay, and then in addition, it is so inexpensive that the cost of shipping, even if it could be done, would exceed any potential profits. So therefore, this type of situation means that there can be differences between the two countries. In other words, in this case, there is no reason to believe that the law of one price will ever hold. So a product such as this, which is perishable and inexpensive, is known as a non-traded good because trade would be unprofitable. Okay, now what about services? Services cannot be traded between countries so that there could be price discrepancies between countries after adjusting for the exchange rate. In these cases, the law of one price does not hold. Okay, so therefore, what we're going to do is claim the following. The law of one price can be expected to hold where, if for goods, where arbitrage is possible. It is not expected to hold for what we call non-traded goods and services. Okay, so therefore, and see what's going on here. This is the background that we need to understand this purchasing power parity condition. So purchasing power parity tells us the following. the spot exchange rate times the foreign rate of interest, or sorry, the foreign price level should match up with the domestic price level. Okay, so if E is dollars per unit, per pound rather, so if E is dollars per pound, then P equals the US CPI, and P star would be the UK RPI. And so what it's saying is that E P star equals P, which is the same thing as saying E equals P over P star. So you can see basically it's a theory which says that the exchange rate is coming from the ratio of domestic to foreign prices. Okay, so E equals P over P star shows that the exchange rate is simply the ratio of the price level indices in two countries. For the dollar pound exchange rate, this means that the exchange rate should equal the ratio of the US CPI to the UK RPI, according to this theory. Now, this theory then, interestingly enough, now, will it hold or not? Well, here's the issue. The PPP rather, is based on the assumption that the law of one price holds for all goods and services. If this is not true, then the PPP, I keep saying the wrong thing, PPP is not likely to hold. So therefore, to the existence of non-traded goods and services means that PPI is unlikely to hold in practice. So now you might say, well, why do we even think about it in these terms? It was more relevant when it was first developed, because there were fewer non-traded goods and services. So it's an idea whose time is sort of come and gone. And even when it was first developed, I think in the 18th century, although I'd have to look it up, it's possible that it never really worked all that well. But, it's basically a starting point which tries to tie an exchange rate to the cost of goods and services in two countries. Now, keep in mind, this is meant to be a very long-term relationship. So therefore, it makes sense that we should try to explain exchange rates in terms of the prices of goods and services rather than interest rates. But unfortunately, because, like I said, so many goods are either non-traded or else there are many more services than there used to be, it's not likely that this will actually work in practice. Oh my God, so what do we do about it? Well, there's a variation of this idea that does seem to work a little bit better in practice. But the absolute version that we're seeing here does not seem to work very well. But like I said, there is an extension of it that does seem to work a lot better in practice. All right, so now, having said all that, you know what, I think what we'll do is maybe we'll stop it right here. We have a sample midterm to work on. And so what I'd like to do is post this tonight, and you can start working on it. We'll go over it next week. It's not really much different than what we were doing today. And then we can have our actual midterm. and then we'll just continue with our new material, and we'll take it from there. All right, so what do you say? Should we knock it off right here? Yeah, I think so. All right, so what the heck? Let's go home. Well, we're already home. Why don't we cut it off for tonight, and then I'll see you all again next week.
Thank you, Professor. Take care.
All right. All right. See you later. Good night.
Thank you.
Good night.
Good night.